Today I'll be performing the prelim laboratory examination in microprocessor. So the first activity is to write and assemble a program to load register R20 with value 99. Then from register R20, we have to move it to R0, R1, R2, R3, R4, R5, R6, R7, R12, R30, and R31. Then we have to single step the program and examine the register. So we have to move to AVR Studio and then to type LDI, the R20, and then the value of R20 is 99. Then we have to move the value of R20 to R0. And then same goes with R1, R2, R3, R4, R6, R7, R12, R13, R14. R1, R2, R3, R4, R6. Then to build no errors, and then assemble and run register. So as you can see in R20, we have the value of 99, and then single step the program. As you can see, the value of R20 moved to R0, and then R1, R2, R3, R4, R5, R6, R7, and R12, R30, and R31. So that's all for activity 1 of prelim examination. So the second activity is to write an assembly program to add all the single character of your last name and save the result in R16. Then single step the program and examine the register. So let's start with R16, and the value of the first letter of my last name, which is M, to its value in hexadecimal, which is 4D. Then the second letter, which is letter A, and its value in hexadecimal is 41. And then here is the value for letter N, letter G, letter C, and letter O. And then we have to add the value of R17 to R21 in R16. And then we have to build, so no errors. Then we have to assemble and run the program. So as you can see in R16, there's already a value of 4D, which is my last, the first letter of my last name in hexadecimal, which is 4D. Same goes with R17 to R21. Now we have to single step. And then if we add the value of R17 to R16, we have the new value of R16, that is 80, because R17 is 41 plus R16 for D in hexadecimal, that's 8E. And we have to add the current value of R16 to the value of R18, which is 4E. So we have DC in hexadecimal. And then add the current value of R16 to R19, which is 47. So we have 123. And add the value of the current value of R16 to R20, which is 43. So we have 166. And add the value of R16, current value of R16 to R21, which is 4F. So we have a new value of R16 that is B5. So that's all for activity number 2. So the third activity is use the simulator, AVR Studio, to single-step the program and examine the status register. So we just have to copy this program and then run it in AVR Studio. So build the program, no errors, and then we have to assemble it and run it. So proceed here in the register. So as you can see, there is a value in R16, which is the FF in hexadecimal, and then you have to single step the program. So we have the already a value for we load the value of 0FF to R17, and we have to add the value of R17 to R16. So the value of R16 is FF and the value of 17 is FF. So if we add this, and the result will be FE in hexadecimal. So the current, the new value of R16 is FE. And then we have to load another value to R16, which is 01. And then we have to load a value to R17, which is 02. And then we have to add the value of R17 to R16, which is 02 plus 01. So the new value of R16 is 03. And then the next one is we have to load a new value in R16, which is 03. And then we have to decrement the value of R16. So the previous value is 03. So we decrement. So the new value is 02 rather. So the next one is you have also to decrement another value, another one in the value of R16. So from 02 proceed to 01. And the next is we have to decrement again. So from 01, the new value of R16 is 00. And then the next one is we have to load a value in R16, a new value of R16. So it is in a binary form, but it is read here in the register as hexadecimal. So we load a 40 in R16. The next one is LSL R16. So the new value of R16 is 80. And then we have to load a new value in R16, which is 0F. So here, 0F. Next one is INC R16. So the new value of R16 is 10. So that's all for activity number 3.